when we started off, the first time we built it, it leaked because the plate itself, the bipolar plate, was bent. So when they were doing the machining, it was like, because of the heat generated, it got bent. So then we had to get into, with the vendor, we had to get into jig design. How do you hold the electrode during machining in order to make it flat, right? Then once this issue is fixed, you go to a scale above. So this is, let's say, 100 centimeters square. Then I'm going to 10,000 centimeters square or 5,000 centimeters square. And the same problem happens, but in a different way. So then you have to fix it also. So it's a mix of scientific, technical, and manufacturer challenges that we had to solve. And now finally, we are at a stage where I can say that, hey, I can make it. But now how do I get the cost down? Because in the end, I have to compete with China.
Hello and welcome to another episode of Specially Focus, where we explore the frontiers of India's deep tech ecosystem. Brought to you by Specially Invest, a leading early stage deep tech VC firm in India. I'm Hariarakli, and in this episode, we sit down with Prasanta and Rochan Sinha, founders of Newtrace in Bengaluru. Prasanta and Rochan spent close to a decade in Europe pursuing their respective careers in aerospace and advanced materials before returning to India to tackle one of the most pressing challenges in climate tech, making green hydrogen an affordable reality. Newtrace operates at the unique intersection of hard science, hardware engineering, and sustainability. Starting with the idea of developing a groundbreaking membrane-less electrolyser, the two entrepreneurs have found their first commercially viable product in a core component, the electrode. Coincidentally, we recorded this episode on the day they announced their latest fundraise, 56.9 crore rupees in pre-Series A investment. The two founders share insights on navigating the complexities of precision manufacturing, the shift from full-stack development to becoming a key component supplier, and their mission to bolster energy security in India. Even as they continue to develop their full-stack system, their proprietary catalyst materials offer immediate value by improving the efficiency of existing electrolysers. Through next year, Prasanta and Rochan intend to use the fresh funding to scale their electrode production and launch commercial pilot projects.
You're in a good day. Today we are announcing our current fundraise.
Fantastic.
So it should be out in the media as we speak right now.
That is Series A, is it?
Pre-series.
Series A.
Yeah.
The previous one was seed round.
Seed round, yeah.
And thank you both for making time for this. It was a bit of a drive in Bangalore traffic, but it was so worth it. In my mind, if there's a company in India right now, at least a startup, that is very much at the intersection of, deep tech, hardware,
Right.
bringing hard science and engineering knowledge, and climate tech and sustainability. You guys are like, I think, one example, top of the mind.
Right.
I just wanted to add one other thing, which I really loved. Climbing up the stairs to the first floor,
Yeah.
I noticed on each
Stickers.
stair, you put these stickers with little factoid about hydrogen.
Right.
And again, I just want to throw it in here. People can listen to the podcast to figure out why we're saying all these things.
Right.
But I just thought it was a lovely idea to put those different factoids about hydrogen and how much it's sort of part of our economy and daily life, and we don't really realize it.
Yeah.
Fertilizers that grows our food, and so many. In refineries, and we drive ICE vehicles still and whatnot.
Right.
And you're working to make an impact in all these fields. So I think that's a good sort of longish preamble from my end. I'm going to stop. Let's start a little bit at the beginning. You both are hardcore PhD engineers, scientists. Give us a snapshot of how Newtrace happened in your own words, and we'll go from there.
Sure. So I think so Rochan and I, we met in Entrepreneur First in 2020. It was the fourth cohort of Entrepreneur First in Bangalore. And we came from very, very different backgrounds. But I think we both were passionate about building something in the climate tech space. We wanted to solve a hard problem, but also build something that goes and impacts the lives of people. So we worked across different problem statement to understand what could have the most impact, and then I think green hydrogen at that point in time, considering the industrial impact that it could have, was a very promising problem statement for us. It suited well with our backgrounds as well. Rochan comes from the background of electrochemistry and electrolysers. I came from the background of fluid mechanics and aerospace. So we found early traction in terms of problem market fit. And then we went on to do some initial design and development in our apartments close to Indranagar. And then once we had that, obviously you cannot make a prototype in your apartment. You don't have garages in India, so you can't make it in your apartment. Ask a VC to, yeah. So we can't narrate a garage story in India. We wanted to build a prototype, and we found IIT Madras and CCID to be our home for 3 months. We went there, set the prototype there, and showed that it works. The whole concept of membraneless electrolyzer, where we were not using a membrane and yet splitting water into oxygen and hydrogen. Since then, we went on to raise pre-seed capital and then set up our office in Bangalore. And yeah.
You want to add anything, Rochan? And I know that from previous conversations, and at some point maybe can do it right away as well in the context of why you guys came back to India. You have a backpacking story, and we can get into that, or we can wait for Rochan to talk about his side of.
No, I think we have talked about it enough that both of us have the same storyline for the building up of Newtrace.
Yeah, I mean, I'm curious about why you all decided to come back to India. You, I think, in your own words, you both spent close to a decade in Europe,
Yeah.
and definitely it's much more advanced, both in terms of the ecosystem that you would need to build a company like this, as well as a market, including the regulatory sort of commitment that European governments have for green hydrogen.
Right.
All of those things look so much more attractive compared to coming in, you may not have a garage story, you will have I think, Koramangala apartment story, Indranagar apartment story in Bangalore, I think. Yeah, so I was curious about.
No, so I think obviously we both have different journeys. For me, once I finished my PhD, I felt like I have not traveled across my own country enough. And that's what the backpacking story is. I wanted to travel across the country. So started from Kerala to all the way to the northern part of the country, to Rajasthan, to UP, went to Nepal, Uttarakhand, Himachal. And I think it was just a backpacking because all my stuff was kept in Europe, and I was heading back there. And I think within everything, I wanted to still try and build something in the country. I spent enough time in Europe. For me, the Indian ecosystem looked even bit more cutthroat. The European ecosystem, there is a lot of focus on decarbonization and climate change, but still feels like it's not very, very competitive enough. The Indian startup ecosystem was cutthroat. I mean, you have to survive and build and thrive, or there's so much of talent, so much of competition, so much of work being done in the country. So it felt like a more dynamic environment to be there and to kind of build here. I think that's the journey that I had. I'll let Rochan speak.
Yeah. So mine was actually an accident. I finished my PhD in January 2020, and I think I came back in Feb end of 2020. And 1 week after that, COVID lockdown happened, the first lockdown. And at that time, all my plans of going back to Europe, everything kind of vanished. And then it took me around a couple of months to figure out, what do I want to do? Because the skills I had built in Europe, that was in my PhD and my master's, that I didn't find any, like existing companies, large corporations who were doing something similar in India. Like there was no real R&D focused development at that scale of, especially for green hydrogen or any of that sort. I don't think people even knew the word green hydrogen, or nobody was talking about it at that time. And so at that time, coincidentally, somebody from Entrepreneur First approached me around May of 2020. And they told me the concept how it works and everything, and I decided to join. I was like, okay, let's see how it looks, right? Because I have always been the kind of person who likes to do independent work. Like, I don't want to be told what to do. It comes naturally from inside me, right? So that was an interesting thing for me. And so that's when, yeah, I joined Entrepreneur First, and the rest of the journey Prashant already mentioned. But it excited me in the way that not anything else had. Like, I didn't want to do a normal 9 to 5 job, Excel sheet wala. I wanted to do something with my hands, basically.
Yeah, I had made a mental note, to ask you about this. And I feel like it left an impression in your mind, in the sense that I don't know if disappointment is the right word, that you saw the scene in India was so nascent that you didn't really find like a large enterprise doing
Yeah.
interesting work in R&D or anything. And I want to mention that at this point, because down the line we can talk about how things have changed
Yes.
in these few
Definitely.
post-COVID especially.
Yeah.
Um, can you just reflect on that sense of like, ye kya hai, kuch nahi ho raha hai kind of thing, back
Yeah.
then?
I think at that time, Aether was already up and coming. So I had looked into it, but I didn't want to get into pure mechanical stuff because they were doing cool stuff at that time. And also there was some other speciale portfolio companies like ePlane was there and others were there, but they were all doing work on other fields, which was not very interesting for me at that time. And in climate technology, especially, there was no one doing any advanced research. Like, or maybe I at least didn't find any such job postings or anything from any of the companies that I looked into. And it was, it was definitely disappointing because in Europe, at that time, you already had a lot of research being done by companies, even like companies like Shell, uh, ASML, even every company wanted to get into the green energy, new technology, and advanced materials and electrochemistry is like a core part of research in Netherlands, especially, and that kind of excited me. So it was very difficult for me, that transition, that hey, nobody's doing anything that I am good at in India. And but yeah, I, like you mentioned, things have changed quite a lot since then. Yeah.
Hmm. Can you both now talk a bit more about how the idea of green hydrogen plus uh, building an electrolyzer to make green hydrogen, how did that sort of crystallize in your minds?
Sure, I'll take a shot first. I think so. The world has seen green hydrogen waves or cycles in the past as well, right? The challenge always has been the cost, and when we first started editing in the space, we said, can we just look into arbitrage of geographies and labor and just manufacture it cheaper in the country? Is manufacturing the only delta that we can look into it? And then we quickly realized that the reduction that we might see in the cost of green hydrogen will not be significant enough, and then we'll reach the same endpoint that the production of green hydrogen is not comparable to the fossil fuel hydrogen production cost. Then we looked into, okay, what are the critical materials? And even then and even now, the critical materials are the membrane and electrode. We realized that the membraneless system could be one of the fastest way of reducing the overall capex and also improving the overall operation availability of the system, because the membranes were prone to damage. They were very, very critical material, etc. And I think that's the space that we've identified, that this could be a significant leap in the technology development, and it could have the potential to reduce the cost. Obviously, through the journey, once we kind of built it and learned it, we learned even different facts and things that we were not aware then. But I think you cannot figure those things out as you go through in the journey. And over the course of it, we realized that the electrodes are also a very key part of it, and then we doubled down on our development of electrodes, etc.
Yeah. I think for me, green hydrogen was a natural extension of my PhD. So I have been working on renewable energy technology since my bachelor's, actually. So in my bachelor's, I did work on solar cells. Then master's, I worked on solid state battery materials. So electrochemistry, material science, I have been in that intersection since 2014, I would say. so more than 10 years now. And so that was already a given for me that I wanted to be in the renewable energy space. And green hydrogen specifically, I think as Prashant mentioned, we saw that opportunity coming up. So that was one thing that really helped us when we started off, that we were able to figure out that this is going to go up, right? Like the entire field is going to suddenly expand because of certain things happening globally. And especially in Europe, I think we were already seeing signs of that happen. I think that was, at least from my mind, that was one reason why we went into green hydrogen at that time. And as Prashant mentioned, when we started the membraneless electrolyzer system development, it was something nobody had done before. So there were some other companies doing membraneless designs, but very, very different. And what we were trying to do, nobody had done, where we were combining this fluid domain, use of the fluid domain to separate the gases. Nobody had done this before. And so we were successful in doing that. In the next 2 years, we were able to deploy a 10 kilowatt commercial pilot plant. And we also developed a new technology, another kind of membraneless technology, which we have also actually just deployed commercially. So the what we realized in that period of time, and that is something that helped us, was that the material that is the heart, which is the electrode, the catalyst material, that is what finally decides the cost of green hydrogen, because green hydrogen is around 60 to 70% is the cost of electricity. Now, I don't have control over the cost of electricity, but I do have control over the material that decides the efficiency of the system. So while developing the membraneless system, we had to make extremely efficient materials, because by the nature of the system itself, we could not, if we were using the same material as, let's say, PEM or alkaline, we would not be able to match the efficiency numbers. So I had to make it, let's say, 40% better in order to make it more efficient than the alkaline system. So we had this development of the catalyst materials, and this has accelerated over the last year when we realized that other players have gotten into the market. They want to build up electrolysers, and we were already 10 steps ahead in terms of the materials development. So that's where we saw that opportunity to whatever we had developed for the membraneless system was equally valid everywhere in the green hydrogen ecosystem, basically.
Can you briefly explain in layperson's terms PEM electrolyzer and the alkaline version?
Sure. So alkaline electrolyzers have been the most oldest technology. It uses water with an alkaline solution. Typically uses materials like nickel-based electrodes and stainless steel to develop the whole system, and consumes around 55 units of electricity to make a single kg of hydrogen. PEM are electrolyzers which operate on an acidic medium, have platinum group electrodes in the anode and cathode, and consumes around 48 units, so 4 to 5 units lesser than alkaline system. The other difference is that alkaline systems are a bit larger in footprint, PEMs are a bit compact, and PEM systems can actually fluctuate very well with the input electricity, which means that they are more suited towards integration with renewable, which are not stable input. Right? Alkaline systems are larger, bulky, but I would say the industrial workhorse at this point in time.
And is PEM an acronym for something, or
proton exchange membrane electrolyzers? Yes.
okay, always.
Just basically.
So can you guys take a step back and just talk about the bigger picture context? I mean, for a wider audience, can you talk about basically it will explain the significance of the work that you're doing. And I think even 3-4 years back, close to 100 million tons of hydrogen today that might have increased. And the cost of that in terms of CO2 emission is like some 10x or something like that, right? So give us a sense of that. Then
Sure. I think the significance is even more evident in the days that we are sitting in today, with the energy crisis that the world is facing. And I think currently today I was reading that there is LPG crisis in Mumbai and Bangalore, everywhere, right? It's even more significant. While we started with a view on impacting and working on climate change, and this is still true, the world still produces 100 million tons of hydrogen, which is responsible for 1 billion tons of CO2 emission. We are producing in India around 6.5 million tons of hydrogen from natural gas and coal. Now, what we don't have right now is an access of natural gas, where the whole country is facing a challenge of fossil fuel supply at this point in time. But the significance from an Indian context is on energy security. And the government is also focusing on hydrogen, not from perspective of climate change at this point in time, but from perspective of energy security. So what has happened in India in the last 10 years is that the input materials to produce green hydrogen, which is essentially the renewable electricity and water from desalination, they have gone down in the cost curve drastically. And they are both available locally in the country. We don't have to go anywhere to source them. Now, if we could make those machines which can take the water from desalination plant, which is available near the coast, and if we can tap into our renewable electricity, which is produced at the lowest cost in India currently of all the world, we can actually produce a greener fuel that can replace our fossil fuel in the industry and even at homes. So just to let you know, we have done a pilot where we are trying to make a modular electrolyzer to demonstrate a cooking stove application for rural application. Right now, when the country is looking at LPG crisis, that could be a solution. You're not looking at it from a climate change perspective, but you're looking at access to energy for everyone right now. So this is the overall impact that everyone's looking at. Can green hydrogen come and power our large sectors, large industries, and provide the fuel to them? Obviously, on top of it, the fuel is cleaner. You have no CO2 emission. All of those are secondary benefits that the industry is looking at. But the primary focus at this point in time is how do we access cleaner fuel at affordable prices?
Okay. One other question, or just a point to include from a general audience's perspective. What is a good definition of what green energy is? I mean, globally, what is an accepted definition today?
Right. So, hydrogen currently, as I said, the hydrogen production from fossil fuel, to make 1 kg of hydrogen, you are emitting around 9 to 10 kgs of CO2. The definition of green hydrogen is that from well to wheel, the CO2 emission to make a single kg of hydrogen has to be lesser than 2 kgs of CO2. So that's around 5x reduction in the CO2 emission to make a single kg. And it includes everything from your energy generation to desalination to the production to the final delivery. It has to be less than 2 kg of CO2 per kg of hydrogen.
Okay. So now let's talk about the technologies and the products that you're currently working on.
Yeah, so so we have developed the membraneless systems, which I mentioned. We have deployed commercial pilots at various sites with PSUs, and beyond that, like I mentioned, we are now working on the component level as well. So basically, what happened was that when we started off, there was no ecosystem in India or no infrastructure to get any support from. So when we started off, we actually built the entire system from scratch. So many times we had to basically reinvent the wheel, and we everything from the materials for the actual water splitting, which make it more efficient, up to the entire system design, engineering, and the software to run the system. Everything was done by us, and this gave us a lot of insider knowledge on how to make the materials better, how to make the stack better, everything which is part of the electrolyzer system that we finally want to make, right? And so today we are focusing also on the component level as well, which is basically the main thing that we're focusing on right now is the electrode, the catalyst material that drives the water splitting, basically. And what this means is that you need some amount of energy to split water into hydrogen and oxygen. The amount of energy required has a certain theoretical limitation, right? So let's say something around 39 units of electricity per kg of hydrogen produced. The closer you are to this theoretical limit, the less electricity you use. And like I said before, the levelized cost of hydrogen, 60-70% is the cost of electricity. So the less electricity you use, the cheaper the hydrogen will be. So our goal has been that we want to get as close as possible to this theoretical limit, right? And this is what we have been working on over the past couple of years, is to build these materials better. And the second part is that we don't want to do it at lab scale, right? Lab scale is okay for academia, but for us, we want to show that we can give it to partners who are, let's say, or for our own systems, making it up to, let's say, 10,000, 25,000 centimeter square scale. So like 2 meter diameter, right? Like that's taller than you are, basically. And so we have developed not only the facility to explore new materials at a lab scale, but also then scale them up. So we have a final catalyst coating unit. We have systems to run these coated electrodes and test them out, make sure that they are stable, they are performing the way we want them to, so that we can give that guarantee to the customer as well. So this has been going on in the last couple of years.
Staying on the electrode part. So, as I understand it from a layperson's point of view, now what you've innovated is, or you're developing material for electrode, which will bring you as close to this theoretical limit as
Yes.
possible in terms of the least amount of electricity needed to make 1 unit of hydrogen volume. Yeah,
Yes. Yes.
okay. So, on the commercial front, this translates to an electrode that you can sell to anyone. Is that how it's coming out now?
Yeah. Earlier we were the full stack developer. We were developing the entire system, which was membraneless. And then we realized that the market was still nascent, right? People have to put up capacities. At the end of the day, the goal of the company is to deliver the lowest cost of green hydrogen. But we never said that we are going to do it all alone. So we have to work with the industry. We realized that a lot of larger players have announced plans to manufacture in the country under the National Green Hydrogen Mission, and they have taken technology licensing from global players. And the risk there was that India would become a slave to the supply chain of critical materials from the global players. And we said this is a problem statement to address while the membraneless electrolyzer goes through its own development and validation cycle. So we are building for the long term. And in the interim, we said the electrode is the strongest product suite that we have at this point in time and can fit in with a large level of manufacturing that people are planning to do. And can we deliver that to them? Right. So this electrode that we're developing is for membrane-based alkaline electrolysers, where we are telling them that if you get the entire stack from even, let's say, any neighboring country, if you drop in our electrode there, replace the existing electrode with our electrode, you'll have a significant gain in the efficiency and reduction in the levelized cost. And that is the simplest value addition that we are offering.
So where are you at in terms of commercializing this electrode now?
The electrode is going through its scale up at this point in time. So we are looking at obviously performance is one criteria that we are looking to validate, but also the degradation and the lifetime is something that we are testing extensively. So we are currently scaling the electrode to larger and larger sizes and testing it. I think we have a timeline to test it up to 10,000 centimeter square. So we will commercialize the electrode towards the end of this year.
Can you explain the 10,000 centimeter square? Is that like surface area of the electrode?
Right. So electrolyzers, typically people talk in megawatt sizes, right? And when we started off, we thought 1 megawatt was the largest world that has seen. Very quickly, it became that the 5 megawatt was the largest that people have seen. And it's essentially a lot of large circular discs which are compressed together. Now, a 10,000 centimeter square is a circular disc which has a diameter of around 1.2 meters. And the world is currently operating at 5 megawatts, which are at around 25,000 centimeters square, which is roughly around 2 meters in diameter. So our goal right now is to make larger and larger circular disc of electrode, coat it with the electrocatalyst and test it and validate and prove it. So over 1 meter to up to 2 meter sizes in diameter.
So the material composition of your electrode, that is also proprietary to Newtrace now.
Yes.
Is it? Okay, fair enough.
The important part is that we are delivering the performance that people obtain from PGM metals. So if you put a lot of platinum, iridium, which are rare earth metals, whatever performance they would get, we are delivering performance at par or even better than them without using a PGM, and that is a novelty that we are offering. So the cost of the electrode will be cheaper and the supply chain will be well sorted out.
Okay. So who might be your natural customers for this electrode?
Right. So we have manufacturing being set up for traditional membrane-based electrolyzer by the likes of L&T, Reliance, AM Green, all these players who have large offtake and project announcements. And as a electrode supplier, they become our natural partner and extension to supply to them. So we, as soon as we have validation data with us, we'll go and kind of get into deeper conversation with them.
Okay. So the full electrolyzer, sort of a parallel development, but it could have
Validation.
a longer journey in terms of finding a market.
Right.
Okay. Uh, so can you talk about some of the challenges that you faced or you have faced along the way so far, and then we can also sort of move into some of the lessons that are coming out of this experience over the last several years. I mean, both technical challenges as well as, like you said, you discovered that
Sure.
um, the electrode has become the most attractive immediate product.
Right.
So business as well as technical.
Sure. So I think that overall, the green hydrogen sector in the country has seen a lot of challenges. So the government, through its 19,700 crores of National Green Hydrogen Mission, showed its intent to support the ecosystem to kind of grow into a full-grown ecosystem in the country. But the challenge has been that the offtake of green hydrogen has not been very, very strong, both domestically and in international market. And if the final customers are not willing to offtake the green molecule, then finally the downstream production ecosystem does not develop. And I think that has been one of the key challenges of the whole sector, why the production of green hydrogen, the production and manufacturing of electrolyzer and then subcomponent ecosystem has not grown drastically as planned by the government. I think there have been some indication from the government that we might miss our targets of the National Green Hydrogen Mission as well, right? Now, that has been one of the key challenges, because you can incentivize the production of the molecule, but you also have to incentivize the off-takers to take or put some mandate on them. Right? There were talks of mandate on refineries and other industries to take at least 10% of their hydrogen offtake from green hydrogen, but that has not translated into anything substantial. So that's one of the challenges. The second challenge, in my view, is more towards manufacturing. So we have done very well on consumer manufacturing. We have done very well on, I think, certain sectors of industrial manufacturing, but we have not done very well on precision manufacturing. So high value precision manufacturing, the know-how, the capability, the volumes are currently a challenge in the country, and I think we have also struggled drastically because of that. It takes a lot of time to. It's actually cheaper and faster to get something manufactured in China still for certain components than getting it done in India, and it's a function of capability and capacity both.
The manufacturing definitely is the most difficult part that we have had to solve to some extent. And one good thing that has come out of it is that we have learned a lot about manufacturing ourselves, right, in this journey. And we have been able to work with our partners to make precision. The issue is that India has precision manufacturing, but at small scale, like in the sense that you have aerospace, defense, and automotive, where you are making smaller parts, especially in aerospace, but those parts are then very precise. But when you have to make 2 meter, 2.5 meter scale plates which need micron level precision, that is where most of the vendors struggle. So we have worked with hand in hand with vendors over months and months to develop this process. We have made new processes for manufacturing certain components that didn't even exist in India till now, although it was there in the global market. So it has helped us to build a very strong supply chain network, not only for this components but also for materials. So one thing that I think we didn't mention yet is that I think everything in our catalyst, the electrode that we are making, is from India, right? Down from the electrode up to the catalyst materials, the raw materials, everything is from India. So we have been able to develop a very strong supply chain slowly over the last 4 years. And that has helped us a lot now. Like now when we want to move and make new things, it's much faster than it was, let's say, 2 years ago.
Hmm. Can I just go back to the offtake problem?
Yeah.
Why has offtake not been very good? Is it a basic thing like green hydrogen being overall costlier than the conventional, or are there other problems as well?
No, I think Cost is the first problem. India, despite all the gyan, India is a very price sensitive market, and it's driven by, let's say, even for sectors which are not non-existent, is driven by L1 tenders. Now, you cannot have a sector grow from an L1 mindset when you are in the 0 to 1 journey, right? Um, while we have seen large scale project development uh, in the electricity sector, renewable electricity sector, people thought that the same skill set is translatable into the green hydrogen sector. But the difference has been that in that end, you're dealing with electrons. In this end, you're dealing with gases, which you also have to be considered about safety and other aspects. So I think that has been a biggest challenge. The cost has not reached a particular level, and the expectation of the cost, everyone's worried that if they tie up on a particular cost sector, what happens if the cost goes down in the next 2 years. So I think that's the biggest challenge. The second is essentially that we wait for a black swan even before we bring on critical push, right? In aerospace, we push forward the drone sector after we had certain defense related challenges, right? The same way, now we are going through an energy crisis of sorts in the country right now, and I think we'll see that people will be, or at least the policymakers will push for some mandate in certain sectors to kind of create enough volume in the country, and then the price will go down with volumes.
So is there a global problem as well? I mean, correct me if I'm wrong, and I don't immediately remember the name of this company, but a very large industrial company. I think they recently shut down their electrolyzer. Was it Cummins?
You're talking about Cummins, yeah.
Okay. Yeah. I wasn't sure if that's the company.
Yeah.
So what's happening globally?
So Cummins have their PEM electrolyzer manufacturing in US, and I think US is suddenly trying to be the leader in oil and gas production. So they've realized that, and as I said, hydrogen as a solution or energy as a solution will be very, very locally in geography. Right, so they've realized that they will not be price competitive in Asian markets, and in the US, with a sudden interest in oil and gas, they will not be able to drive through enough interest in the sector. So that's why they have, I think, halted their manufacturing for electrolyzers. But I think for countries like India, China, and for Japan, Australia, it still makes a lot of sense to kind of leverage our electricity and engineering talent that we have available and kind of drive through the energy security journey.
Okay, all right. Okay. On the components front, Rochan, can you give a couple of examples to illustrate how you have now built out this supply chain?
Right. So basically, the electrolyzer system has various parts. I'll stick to the stack because that's the heart of the electrolyzer. The plant is something that India does very well because we have a huge chemical engineering and pharma industry. And so the stack has various components. It has the electrode, like I mentioned, which is the heart where the actual water splitting happens. It has the bipolar plates, which is basically a way of saying that you can stack these electrodes together without anything shorting and without, just having the parallel water splitting across multiple cells, so that if you could just put one 25,000 centimeter square cell for electrolysis, it would produce only, like, let's say 0.5 megawatt or 0.5 kilowatt, right? But then you put hundreds of them, then you can make 5 megawatt in a single stack. So that is called a bipolar stack thing. And those plates, the bipolar components, is a critical part of the stack. And you have other things like the membrane, the gaskets, all of these different components, which goes into making the entire stack. Now, when we started building with the membraneless system. So the membrane was not part of our problem, but everything else was, right? And so when we started off, the first time we built it, it leaked because the plate itself, the bipolar plate, was bent. So when they were doing the machining, it was like, because of the heat generated, it got bent. So then we had to get into, with the vendor, we had to get into jig design. How do you hold the electrode during machining in order to make it flat, right? Then once this issue is fixed, you go to a scale above. So this is, let's say, 100 centimeters square. Then I'm going to 10,000 centimeters square or 5,000 centimeters square. And the same problem happens, but in a different way. So then you have to fix it also. So it's a mix of scientific, technical, and manufacturer challenges that we had to solve. And now finally, we are at a stage where I can say that, hey, I can make it. But now how do I get the cost down? Because in the end, I have to compete with China. right? And that is where we are now building new technologies to get the cost down even further by changing the manufacturing process itself, like moving away from conventional milling and these kind of things and going to certain new technologies that we are building. So these uh, this is a iterative process basically, but the supply chain builds up because every step we take to solve the problem, we develop a new vendor, or we develop the talent in that vendor where we made that technology. So then the entire industry grows up. It's like the automotive industry, what happened with Maruti in Manesar. When they started off, there was no tier 2, tier 3 vendors, but slowly Maruti also helped them, and they grew into like these big piston companies and whatever valves companies, which came from the input from Maruti.
Very nice. Any other points you all want to add in terms of lessons from your experience? I mean, it was wonderful to get a sense of how you started with an electrolyzer and then uh, decided that the electrode has a lot of promise as a more immediate product. And of course, through the course of the conversation, you mentioned other things, and how market factors led you to go from the electrolyzer to the electrode itself. Anything else that comes to your mind in terms of building a hardcore deep tech hardware company out of Bangalore, India?
I
Lessons.
think one thing I just wanted, so one thing is that I think you shouldn't get too attached to the product, because, so for example, when we started off with membraneless, we were
Was
fully
that counterintuitive?
yeah, it is, because when you, especially as a technical person, you by nature of the process, you get attached to what you're building, right? But as the founder of a company, which the goal of the company is to grow, right, and survive and become larger and serve a purpose, which is to serve customers. So as the market evolves, you have to evolve with the market. You cannot say, hey, no, I am making this, so I'll keep making this. You take what you have and you see how it fits into the market, and you give the market what it wants, right? And this has something that I personally have uh, evolved a lot. When I started off, I was purely like, nahi, ye product, this is what matters, and but it has evolved over time, I think. So founder market fit.
Yeah, I think you have to be attached to the problem. In deep tech, you can always think that no, what I'm building is ahead of the generations, and you can get swayed in that. But what you have to understand and kind of stay close on the grounds again and again is and reiterate that, are you solving a real problem or not? Your technology can be ahead of years, but somebody has to use it to create an impact. I'm not talking of monetization, but I'm talking of, will it be useful for anyone? Right? And I think that's a fundamental question that every founder has to ask. Otherwise, you will be keeping on building novel technologies, but you will not find an application for that.
Mm. And how have things evolved in recent years in terms of some of the other potential applications? It could have been like long haul mobility or any other applications you may have considered earlier on.
Right. I think right now the industrial use case has been the more prominent focus for everyone. I think India has rolled out green hydrogen supply for refineries, and as well as large scale ammonia tenders for the sector. And I think it also stems down from the point that we have massive renewable energy generation, which is happening in 6-7 hours period, and not enough offtake of that as well, right? So there is a lot of curtailment which is happening. What we mistake is that we think that energy capacity translates to energy. It does not. Right? India still produces around 73% of its energy from coal. So what we have to kind of solve is round the clock energy access, renewable energy access, and I think that those are the few low hanging fruits that we have to kind of attach. People are looking at battery energy storage systems for solving that problem, but in all of this, what we have done is we have pushed the prices so much lower through this arbitrary L1 tenders that a lot of them will not go into action as planned. So we definitely will have to do some course correction in the country in terms of energy infrastructure, look into our energy infrastructure, not only from cost perspective, but from an availability perspective.
Again, for a wider audience, can you explain the L1 tender a little bit and the impact here?
Sure. So I think for everything in India, we have procurement process driven by the lowest cost, and whenever we are trying to give out certain new sectors, for example, battery energy storage or hydrogen, we do not do a very strong techno-economic assessment of the participants in the, let's say, tender or in the process. It's purely driven by the lowest cost bid the people make. And a lot of time we have seen that people make arbitrary price bids just to be in the news or out of it. It impacts companies like us, which are trying to do hardcore work, and you will never be in a new sector price competitive from day one. That's an illusion, right? Every founder says that you will be 50x cheaper or 20x cheaper, but from day one, I don't think nobody will be cost competitive. You have to figure out different ways. You have to solve different problems to be price competitive. So the L1 in energy is kind of driving the prices low, and we are seeing a lot of non-serious participants coming and entering a sector just to get their names in, right? And then when the real execution of the project should happen, nothing happens, and then we go back to the drawing board again. So I think we have passed those feedback to the policymakers, and I hope things changes in the country in the near future.
So I mean, to translate, you're saying someone with sort of deeper pockets can jump in and maybe even use.
Yeah, right now you don't even need a deeper pocket right now. I think we have heard of a company which was earlier in biscuit manufacturing and all of a sudden had a bid for energy storage systems. Now you can make a very nice Excel sheet that you'll get this from China for this cost and put this up and land will be this and all. But what you don't account for is the integration cost, and that is the kind of insight that a deep technical company or deep sectoral company will have, which a non-sectoral company will not have. Right, so a lot of bids are made on Excel sheets and not on real ground execution experiences.
And to the point on curtailment, what are the missing pieces of, say, getting power from wind or solar and powering an electrolyzer around the clock? What are the missing things over there?
I think the availability of renewable power round the clock is a challenge. For example, solar is available for a brief period of time in the day, and beyond that, and wind is also very, very seasonal, right? So we have wind availability during the monsoon. During the non-monsoon period, the wind availability factor actually goes down drastically. The missing piece is the long-term energy storage, which India is trying to solve through pumped hydro, right? And this is where, when you have available cheaper renewable, you can pump in water from a lower lake to an upper lake. And when you don't have the renewable in the night, you can actually pump in the water and run turbines to do that. India is also looking at availability of battery energy storage systems, but they are only being looked into from a grid stability perspective for a 2 hours or 4 hours in the evening. Right, so when the solar is not available and there is a huge peak, but there is a lot of work that has to be done. I think India is also pushing on the nuclear energy just to make sure that the baseload energy is available around the clock. So there is a lot of work that has to be done in a perspective of making sure that the energy requirement is met around the clock with renewable power. And some of the companies globally are looking into gas turbines powered by hydrogen also. Right, so when you have available solar energy, you can split water, store the hydrogen, and run gas turbines with that when the solar is not available. So a eclectic mix of different sources and forms of energy will come in and fill the energy curve which is required.
So even with the energy storage system, so what you're saying is that you need that sort of 24-hour
Correct
storage requirement. I think, again, we are at a stage where now startups are just beginning to build some of those. I mean, I'm familiar with Mind Electric in Chennai, and they're precisely talking about this 12 to 24-hour sort of period. Okay, I guess we have to wait for all these things to develop and
Absolutely,
scale. Okay, let's bring it back to Newtrace. For you guys, what comes next? And I think you have funding, you or recently had a funding.
Sure. So we are announcing our pre-series A funding of around 56.9 CR. Apart from our existing investors, which are Speciale, Avishkar, Peak 15, Micelio, we are also having new partners, HDFC Bank and Mitsui Sumitomo Insurance Venture Capital in our cap table to come and build Newtrace with us. The funding is intended to scale up our electrodes to the largest sizes that we talked about, and kind of drive down the first few commercializations and pilot that we'll be do with the product. So we have a very extensive plan of testing these electrodes out. We also have some plans to take them to different other geographies and test it out with our partners. And the funding will support that. The funding will also support the commercial plant which will roll out this electrode.
Okay, so congratulations on the funding. Uh, in terms of your team, can you give us a quick update? I mean, I would imagine even now it's very engineering heavy, but what's happening over there?
We are a 45-member team. Obviously, it's engineering heavy, and but we have seen that you should build a very strong operation support team as well. The BizOps team, which kind of looks into the supply chain challenges, the finances, and everything else. The team split is around 60-70% product development and 30% in BizOps, and I think that's a good mix that we have seen. But we have invested heavily early on building a very strong BizOps to support all the activity that we have done. We have seen that supply chain can be one of the make or break difference between your success, and I think for any early startups, it's a good investment to do to build a very strong supply chain team from early days.
I mean, in terms of the electrode, and maybe later if you want to talk about the whole electrolyzer as well, uh, what does scale look like for you at like a truly commercial level? What would you consider as a good scale for Newtrace?
So I think the 25,000 centimeter square we were talking about, that would be the largest, I think, that is also being used in industry. So that's like a 2-meter diameter electrode that we want to go towards, especially with the fundraise that we have just had, and that is where we are heading towards also.
Yeah. In addition to that, I think what also the team is working on and trying to solve is how many electrodes can you take out in 24 hours, right? And that's the number of electrodes that you can do, because the cost of the electrode will be a function of how many can you take out from each batch of chemicals that we are doing. So there's a lot of work which is being done on the size, but also the number of electrodes that you're producing every hour or every day.
So we're building a very strong team around this as well. So we have from the R&D side and engineer scale-up side, we have people who have experience with electroplating in industry for a long period of time. People who have developed new processes for coating of different materials in the industry, and also people from for the R&D side also we are taking people who have also done studies abroad, who also want to come back to India just like us and join our journey. And so this has been like building that team has been very important.
So on the business front, in the world of hydrogen production, how many electrodes would you be shipping when you consider yourself as more of a commercial entity? Like, in the sense that one good phase of product development and all of that is behind you, and you're selling a lot of products.
Right.
So what will that look like?
Sure. So while if you look into our plans, we at some point in time we want to make 100,000 to 400,000 electrodes in a year, but our immediate goal is around to make around 1,500 electrodes for around 1.5 megawatt kind of systems. We are currently building up the process to see how those 1,500 electrodes look like, what is the processing time, what is the cost, and kind of optimize, and then overall build on capacities. Very soon in the country we'll have at least 3 to 5 gigawatt of electrolyzer manufacturing, which is roughly around 400,000 electrodes in a year, which is required. So we will have to scale up very, very quickly to match that demand here.
So that is the demand in India.
In India,
saying,
yes.
in the coming years.
Yes.
And for you to get to 1,500 electrodes a year, what's the rough timeline?
So the 1,500 one is the pilot production that we'll do, and I think we anticipate to achieve it by the end or early next year. That's a pilot scale when we can say confidently that this works, and we have given out some megawatt capacities to our customers.
And the hundreds of thousands that you mentioned,
that's a timeline from 2030 and beyond.
And that's influenced by the life of an electrode, is it? What is
it's influenced by the number of electrolysers which is planned to be manufactured in the country right now.
Okay, fair enough. And typically, Today, how long does an electrode last, and do they need to be replaced often?
So an electrode typically lasts for around 7 to 8 years. And in a span of around 15 to 20 years operational lifetime of an electrolyzer, the electrode will have to be replaced once. But I think we are very early in our journey in this country right now that we are not looking at a replenishment cycle. Everything that we'll be providing right now would be for fresh installations.
And your business model is about manufacturing the electrodes
and supplying.
and supplying, and so basically selling them,
Right.
servicing them, and
Yeah.
like a regular
Correct. Like a component supplier.
component supplier. Okay. So over the next, say, 18 months, what are sort of the top priorities?
Build the largest electrode possible, test it out for as long as possible with as many different variations possible, and roll out the 1500 electrodes to the customers for pilot scale demonstration. I think if you do that well, it will open up the next set of commercialization for us.
That's it for today. You can find links to Newtrace's website and its founders' bios in the show notes. If you're an aspiring founder in India, especially in the area of green hydrogen, do look them up. I'll be back with another episode of Specialty Focus. Until then, it's goodbye from me, Hari Arakli. Thank you for joining us.